polygons, know your prefixes. Example, hepta is 7, etc. Know the formulas. Identify ice, interior, central, exterior. Inscribe polygons. Most common are triangle, trapezoid, and pentagon. Tessellation, so that's just tiling. Usually one question on tiling, usually. Questions involving variables, so make sure you know, we did that in today's AC, right? Finding X or Y or whatever the variable is at play there. Let me scroll down a bit. Almost done. We're going to have backwards questions, so you have to find n. Some chapter 8 stuff. Back to Renos, like focus on Renos, maybe look at your old test or go try a few in chapter 8. We're gonna conversions. I'll get rid of conversions, and I'll go scale factors. Scale factor K, right? And there's the chapter test that I made reference to. There's a review on 54 to 69 plus more. Like if you look at the keys, basically the back of this booklet is all keyed out and posted, right? And I'll give you a quick review on scale factors. I find it helpful to have these checklists, even if you review for the exam, right? So what I suggest my students is at the very front of the booklet, you say test checklist at the on page 80, wherever you wrote this down. So when you take your booklet and you want to review, it's like, well, I need a big picture before I start reviewing. I kind of need to know what are some of the key points that I'm going to have to be prepared for. So write this down on the front or in the front. Let yourself know, hey, uh, test checklist on page 80, wherever you copied this down to. And I'll review. I'll just give you a quick example on scale factors just so you remember how to do it. I'll use 81 or whichever page you have available there. You should have more than one blank page. We're good? Okay. So what do I mean by scale factor? Well, you should be able to find the scale factor. Review finding K. Right? So example, the original shape or whatever is being talked about is 245 squared inches. The new shape will be enlarged, let's say 516 squared inches. What's the scale factor? Well, scale factor is always new over original, correct? You remember that part? Or model over actual, depends on the scenario. So what I need you to remember is we're talking squared units, correct? So you want to make sure you put that, you put squares. You're like, okay, that means that the scale factor right now is squared. And so you go 516 squared inches over 245 squared inches. Perfect. It cancels out. That's what we want. And here you're going to have to take the square root in order to get the correct scale factor. So you go k is equal to, I just made this up, so I need to, 516 divided by 245, that's that. We go second x2 to take the square root. So I'll show that intermediate step here. So that'll be 2.106 dot dot dot. And then we hit enter. That's 1.45 is the scale factor. Or we could state this as a percentage, right? We go times 100 or 145.12%. Always base it on the calculator. What's on your calculator when you're actually multiplying by 100, right? How much bigger is the new shape? You remember? 100 is your baseline, so it's 45%, 45.12% bigger, okay? New is 45.12% larger. This is just an observation. I'm just reviewing here. And once you have your scale factor, I can ask you anything else I want, right? Let's do that here. If the radius, let's say it was a tank, if the radius of the original, let's go radius original, was 7.2 inches. What's the radius of the new? That could be a follow-up, that could be a B. And I'm not telling you I'm covering all of it, I'm just warming you up, right? So, okay, it's just radius, correct? It's just inches. So we're okay to just use this one. That'd be K is R new over R original. So you plug in 1.45. Ideally all decimals, but this would be a part B, let's say. So it's okay to just use your previous answer rounded because it's not within the question, it's already next part. So this would be X over 7.2 inches. We don't need to square anything because we've got linear, one-dimensional. So you put the 1 here, and that's 7.2 times 1.45 divided by 1. It's not really that relevant. So the new radius of the new tank would be this. Let's do, so this is, let's go, this is part A, this is part B. I'll do a C before we go, okay? Just to help you out. You would help me by just calling it a day, Mr. All right. I'm just making stuff up. So what if the volume of the new was 5,417 cubic inches? What's the volume of the original? What if it asked you that? Remember, we have our scale factor. Now we're using that scale factor to go from one to the other. Oh, cubic. Okay. So that means that K what? I have to consider a cubic scale factor here because my units are in cubic units. This would be 5417 cubic inches. New goes on top. Original goes here. I'm going to substitute that in here. That's 1.45 cubed. It's 5417 cubic inches over, I'm just going to call that X. I prefer you keeping it as a fraction, but sometimes it's not possible. So I'm going to cube my scale factor. That's 3.048 dot 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 is equal to 5417 over X. Put a 1 here. And now we're ready to solve this. This times that divided by that. And notice that I'm using dot dot dot. That means I'm using all the decimals. So it's 5417 divided by 1776.87. What are we in? Cubic inches, because we're still talking volume, all right? There you go. Blast from the past.